Alright, so let's do it again. Let's make progress on our polynomials chapter. Today we learn something easy, just multiplying. We won't learn everything about multiplying polynomials. We'll just learn a little bit. They say you should always leave them wanting more. So that's what we're going to do today. We're just going to learn a little bit about multiplying polynomials. Okay, and it'll start off like this. First we'll start off with the easiest case here. A monomial times a monomial. Very simple. One term times one term. It looks like this. One term times one term. I could tell that it's only one term because there's no pluses or minuses. Those are the things that partition terms. And so everything here is multiplication. It's 3 times x to the 5th times 2 times x to the 3rd. So everything is times. Multiplication. I'm going to do this two different ways. I'm going to do this step by step, very, very carefully, as we know how to do now, because we've learned so much about the axioms, about exactly what we can and can't do. And then I'll do it by inspection. Here it goes, step by step. Step by step may look something like this. Because it's all times, 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 I have 1, 2, 3, 4 things being multiplied. I can rearrange them and decide to just multiply the x to the 5 and the 2 together. And I'll leave the x to the 3rd out here. This is called associativity of multiplication, where you just move the parentheses. That's the symbol we have for associative law of multiplication. Then I'm going to commute these. The x will commute over there and the 2 will commute that way. And there's always two interesting questions here, at least two interesting questions. Is it legal and is it helpful? Well, for sure it's legal because we have something famous called the Commutativity Law of Multiplication. That's why it's legal. And it's helpful because then I can do this. I can put my 3 together with my 2. And I could put my x to the 5 together with my x to the 3rd. And again, I'm using the associative law of multiplication to associate things. I can do that because all this is in fact multiplication, times, 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 times. So there's no pluses here. This will give me 6 by times table. This will give me x to the 8 by just adding the exponents. And so I finish it off with well-known theorems from last couple of chapters that we've been doing. And that right there is a beautiful step-by-step process of how you would multiply a monomial times a monomial. Of course, we've done these things for quite some time now, and you should be rather comfortable with every one of these steps. So much so that you could look at it and you can think all this is going to happen in your brain. 3 times 2 is going to give you 6, and the x to the 5 and the x to the 3rd is going to give you 8, total number of 8 x's. And you could say this is by inspection. So you can do it this way or you can do it this way. This way only if you already know this, if you're already really, really comfortable with this, then you can do it that way. Otherwise, you should do this until you're comfortable with it. Until you understand every single step, exactly what you can and can't do and why. It's a beautiful thing. And that's how we do monomial times monomial. Let's do that again. Again, you could do this step by step, or we could do it by inspection. I'm going to do it by inspection. I'm going to think here that I can regroup the -5 and the 3 to give me a -15, and x times x would be 2x's, or x squared, multiplied together, and that's going to be by inspection. Okay, that's how you multiply monomial times monomial. It's the easiest thing. 4 times 3 is 12. I have x times x times x. That's a total of 3 x's being multiplied together. So that would give me a total of 12x to the 3rd. You can do fractions, no problem. You have 10 times a half. 10 times a half is 5. And you have x times x times x times x 4 times. So you have a total of 5 x's being multiplied together. That's how we do monomial times monomial. Okay? Next, what we want to do is maybe start practicing a different idea. A monomial times a polynomial. So you have one item times many items. They look like this. I have one item here, a monomial. And I have 2 items here, 2 terms. And I know there's 2 because you have the bookmark here, the separator, the plus, which serves to separate terms from each other. And so you have 2 terms here. Monomial times binomial in this case. The reason that's important to note is because that tells you exactly how many times you're going to be distributing. This thing will get distributed 2 times because there's 2 terms. It gets distributed once to each term. So this will be -5x times 3x plus -5x times 1. That, of course, is the famous distributive law. This is the symbol we have for distributive law. Justifies that. This will become -15 x times x will give you 2x's multiplied together, plus negative 5x times 1, that will just give you negative 5x, and of course I'll just say this is by inspection. And there you go, our first monomial times a binomial. Easy. The key here is just the distributive law. Distribute the monomial onto every one of the terms. However many terms you've got here, that's how many times you should distribute the monomial. Here, take this example. You have 1, 2, you have 3 terms on the right hand side. You have 3 terms. That's how many times this guy has to be distributed. Once, twice, 3 times using the distributive law. So this would give me 3x to the 5 times 2x to the third plus 3x to the 5 times 2x plus 3x to the 5 times negative 3. This of course is the distributive law. You can use the symbol or you can use the letters, distributive law. And now you have 3 little baby problems of monomial times monomial, monomial times monomial, monomial times monomial. You can think about them as 3 little problems. This would be 6x, and I have x, 5x's, and I have x, 3x's. That's a total of 8. This of course would be 6, and I have 6x's, and this will be negative 9, and I have 5x's. Okay, and of course that's it. That's how you do a monomial times a polynomial. That's one way to do it anyways. Alright, so let's do another one, but this time I want to emphasize a different idea. Remember a long time ago when you were a little kid and you multiplied numbers? And I mean multiply numbers such as this, 234 times 4, for example. The way you would multiply numbers would be something like this. 4 times 4 is 16, 3 times 4 is 12, and you carry these things, and then you get something like this, 936. So this idea, this is how you multiply numbers a long time ago. We could possibly resuscitate this idea and apply it to multiplying with polynomials. In this case, it would look like this. You would first stack them. You would go 4x squared plus negative 2x plus 5. Then you go times 3x. And then you would do the same thing that we did here. You take the 3x times the 5. That's 15x. The 3x times the negative 2x. That would be negative 6x squared, because x times x would give you 2x's being multiplied together. And then 3x times the 4x squared. That's these two. That would give you a grand total of 12. 12, and how many x's? I got x times x times x, 3 x's total. And so that would be using the kindergarten method. That's how you would multiply. One way to multiply monomial times a trinomial. It's a way of distributing using distributive law, using the kindergarten method. Alright, this is in preparation, of course, for what's coming up. This is too easy. Monomial times polynomial. Maybe a better challenge would be something like this. Let's see here. A binomial times a polynomial. That might be a little bit more challenging. So come back and we'll do a few of these.